Okay, hello boys and girls, welcome back to the Land Rover Toolbox videos. Right, I'm just running the wire through this mighty MIG, and you can see it's just pulled the liner out. Luckily with these cheap MIGs it's not too much of a problem. I'll just put the tip on, push it back in, and it should be fine. I'll just give you a little tip here, as we're here for giving you tips and tricks. Get used to using a pair of side cutters for cutting your wire, and I'll tell you why later. Right, so I need to go on a little bit more about safety because I have a kitchen window here into the workshop. And it's not fair to give people radiation, especially since sparks are something that people are attracted to. So what I have here is a proper welding curtain, and I'll just show you this by hanging a lamp on the other side. You can see that it is actually like a welding mask, so this will protect the people in the house while I'm working. It's just something to think about while you're welding. Other things to think about, and actually this is very important, is flammable materials in your workshop. You can see here that I've used a lot of sheets for draping over the equipment, and I did have a lot of paint stuffs in the workshop, but now I've put them all into a cupboard out of the way to make sure sparks don't hit anything, especially things like lighter fluid. Now I just want to show you something. This is our workshop and our welder, and we have a bench here for grinding and cutting. You can see there's no clutter there. However, there is a drum just over here for oil contaminated rags. You can see that. On this bench over here it's a mess because there's a bin right next to it. Now somebody did actually set light to this bin the other day when they were welding because they weren't paying attention. It's especially bad if you're actually gas cutting as well, because the sparks can cause flames, so you have to think about this. So the workshop floor and the area has been cleaned, you can see that. I do have an issue with the cover that's on the wall at the moment. However, there's no flammables that are readily available to burn or burst into flames while I'm welding. It makes sense, doesn't it? Now, fire extinguishers, ABC, which is wood, electrical and fluids, okay, it's the best thing to have in a workshop. I would suggest you go and research about the type of fire extinguishers you need. I've got 3 small ones in the workshop just in case, and I know we're not covered by health and safety regulations, but fire extinguishers should tell you if they have any gas in them or not. Right, so power supplies. We have here a welder which is actually on 3-phase electricity. Now you always check your plug connections, make sure that they're not loose, and you have the correct supply for your welder. Now 3-phase, especially with extension leads, they have to all comply, so you're not going to burn any cable. Now I'll show you here I have a pay-as-you-go meter. And down here is the fuse box, which is RCD current protected. Now these trip switches are excellent. The maximum is 32 amps. And I'll just show you here, this is actually the main supply to 2 dwellings in this block. On the other side we have the plugs, which are 16 amp rated at the moment. I've got an electrician to do that. And the plug which I've fitted on the Power Welder is 16 amp. At the moment it's on a 13 amp plug, which is sufficient for the amperage I'm going to pull on this, but I'll need to get it modified, so I'm going to have the electrician in to make sure we have an extension lead and the correct plug fitted to the wall. This is quite important, and when you're actually welding you have to make sure that you're not going to blow fuses in the house or cause fires or electrical fires, because I know some of you might have older electrics fitted to your house. Just be aware of that. Okay, so what I'm going to do here is show you a little bit about welders, and I'm going to avoid calling this a MIG welder because you'll see it later on in this video. Now first of all we have the Fluxcore welder. I'm just going to show you the controls. Basically you have a minimum maximum amperage, okay, that's 2 settings, plus you have a wire speed. Now this automatically senses the amperage that you're going to use when you're welding. Now the more you turn your wire speed up, the faster it will go. You can see this, the faster it's going, supplying more wire. Okay, so generally these little welders, they are a push type of welder because what they're doing is they are pushing the wire through to the lance, if you like, or the handle. Okay, you can see the drum rolling. There's a couple of rollers, I'll show you those in a minute, and it will push the wire through to the torch and to the tip. And as I said, as you turn the wire speed up, it will revolve faster. It's not the drum that's rotating, the drum is actually being pulled by these little rollers. Now I'll show you these little rollers just down here on the welder that we have. And you have two rollers here which clamp onto the wire. You don't want to clamp them too tight. And then it pushes. If you have any problems, the wire feed is not correct, it might be because the rollers are clamping too tight or they're too loose. Right, so this welder here, it has electrical information. This is a wire speed control. This is broken, and down here we have, when I get down to it, we have a couple of torch fittings. Okay, well, this is your lance fittings. This one is just a push MIG, and this is a push pull. We can get into that later, but not now. This is a fine setting, and these are coarse amperage settings. So basically you set your wire speed and your amperage, and then you fine tune it with the finer settings. And I always get confused on this knob because it's the wrong way around. Okay, so this welder, some people call it MIG welder, has a gas cylinder on it. It has a shut-off valve, and it has two gauges to tell you the pressure of the cylinder and how much pressure is going up to the nozzle. Okay, basically the cylinder will always give you information of what gas is in there. Now basically the gas is to protect the weld zone from atmospheric gas that can cause defects, and this is actually very important. Because atmospheric gases such as oxygen, hydrogen and nitrogen can cause all sorts of defects in your weld. Remember the word hydrogen because we will go into that later in different videos. Now if you look at this label, it says there is a Cougar which has 5% CO2, 2% O2 and argon. Okay, so argon mixed with 5% carbon dioxide and 2% oxygen. This gas would make it an active gas which is used for various steels, and it extends the range of steels that can be welded with this mixture. It also improves the arc stability, and that's the extras that have been added to argon. Argon in itself is inert gas, but it is virtually for all metals except steels. Now, are you surprised at this? Okay, so carbon dioxide, you probably know it as what people would use pub gas for little MIG welders. Well, surprising they're called MIG welders, but basically it is an active gas. It's oxidizing, it's cheap, and it's unstable deposit rates. This example here looks like it's had a gas which has oxidized the metal around it. Okay, so shield gas can be either inert or active. So why do we call some welders MIG welders when they actually use an active shield? With inert gas, there is virtually no reaction with a molten weld, whereas the active shielding gas is directly involved in the actual welding process. It causes the direct forwarding of the metal material to the welding point, and beyond that stabilizes the electric arc at the same time. Thus, the use of active gas is mainly suitable for metal arc active gas welding, MAG welding. On the other hand, inert gas is usually used for metal arc inert gas welding, MIG welding. There's just something to think about it. Now you've heard it, forget it for now. And then when people say MIG welder, then just have a look at the gas and see if it is actually metal inert gas or metal active gas. Okay, I have to apologise for the video quality here. It was a bit of a rush at work. Right, so I take the gas shield off, and what I have on the end of the lance, as we call it, is a welding tip where the wire comes through. Now this will be the same size as the wire, or just a little bit bigger. Now the part here is where the gas comes through the torch, and the shroud makes sure that the tip is shrouded with gas. Now that's easy enough, but basically you want to make sure that this is always clear and has not got anything stuck to it. Okay, as I said earlier, always use a pair of side cutters with your wire feed to trim your wire. Some people are too lazy and they start to shorten their wires out on the earth clamp just to get the wire shorter. Now basically this makes a real mess of the earth clamp. Really, you should always have one that's in good condition that clamps to the work properly, okay? It does make a difference, and it's like a vehicle automotives. If you have a bad earth, you have a bad contact. Okay, so the simplest manual metal arc welder, this is 3-phase and single phase. Unfortunately, you can't put it on both, you have to wire it from the inside, but it is possible to turn this into a 3-phase welder. This is on single phase, it has a positive and a negative, and this is your amperage control. It's as simple as that. Basically, you have your rods in there, and this controls the amperage that is coming through to your welding stick. Up here is an indication of the controls. However, this is a little bit old, and surprisingly it still works. And somewhere faded here in hieroglyphics is the information about what voltage it is. Now, both of these are live. Once this is contacted your workpiece, this always stays live. So I haven't got the welding stick in there at the moment because I don't want it arcing out onto the workpiece. So we've moved into the 21st century, and this is a 21st century welding equipment. Now I've got it set up for stick welding or manual metal arc. Basically, I have the positive, which is the stick holder, and then the negative, which is what you could call the earth clamp. You can see that, the negative there. Now this is set up at the moment for AC welding. I'll just switch this on and let it warm up a little bit. I've got to select AC, and then I need to set it on to manual metal arc. Right, so I'll just put this down to manual metal arc. It's 110 amps, and I can very finely adjust the amperage on here, which, to be honest with you, is very important that you see amperage these days, and then it will tell you what voltage there is at the moment. This obviously changes when you start to demand amperage from the machine. Now I'll switch this off, and I'm now going to swap these around. This is quite important because we're now getting into inverter welding, which is DC welding. DC welding has advantages. It has quite a lot of advantages. I put the negative into the positive, which is clamping your earth positive, and then I have the stick, which is the negative, as it were. Okay, I'll put it onto DC and then down onto manual metal arc, and it will remember the last setting I had on there, which is pretty good. Now we have to get into this because this is the new age of welding. Once we have a machine like this, which is really cheap compared to how they used to be, we can do a lot more. Okay, so welding rods for manual metal arc welding. I think these came from the Netto Superstore. These are only 300 millimeters long, and these would have come with a DIY welder. Okay, so it does tell you what amperage to use, which is 55 to 95 amp, and the positions that you can weld in, which is vertical and overhead. And it doesn't give you any more information than that. And it's really, to be honest with you, I wouldn't use them. 6013 is a code for welding rods, and basically this sort of information, the words like Rutal, MMA electrode, which can be used at DC or AC, will obviously give you more information that you need to know, and it tells you the amperages to weld with, which is a lot better. Now, E718 also is very good for steels, and these are not low hydrogen rods. You really need to avoid low hydrogen rods. We'll get into that later. And of course, power weld, these ones here, E6013, which is all positions general welding. Okay, now these are 3.2, and this is what I've chosen to weld our chassis with. And in the following videos, we'll start to use a stick welder on some thick steel, and I'll explain all this later.